David Smith here with another Flipped Classroom math video. A few tips before we start. Remember that you can slow down or speed up the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or try the problems before I explain them. Lastly, you could turn on the captions and read my words going along below the bottom of the screen. Today's topic, multiples of 30 degrees and 45 degrees. So this is going to begin our work carving up the unit circle in certain chunks. And we're going to play with radians here, so I really want to take a minute to convert those. 30 degrees is pi over 6 radians, and 45 is pi over 4. We'll talk a little bit more about exactly how I came up with those as we go around. So, we're going to start with the multiples of 45. They're a little bit easier because they divide the 90s exactly in half. So we'll come halfway up to 90 at 45 and then another halfway. Okay? So what we want to do is talk about the x and y coordinates of these points at various multiples of 45. And let's draw some lines in here. This would be our theta, and it's 45. And then this would go there. So all of these little angles here are 45-degree angles. Okay, so you could write theta, 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 theta all the way around, but I don't want to clutter up my diagram. So first, before we start taking a look at the coordinates of these points, let's list the coordinates that we know. There's some easy ones. Remember, this is a unit circle. So think for a second, what's the coordinate of that point? That one is 1, 0. We haven't gone up or below the x-axis, and we're all the way out on the edge of the unit circle, so this distance is 1. That's a radius. So that's 1 in the x direction, and the y direction is 0. So take a minute and populate that point, and that point with the same information. Okay, so this one over here is going to the point 0, 1, and then this one over here is negative 1, 0, and then this one down here is 0, negative 1. So those points are for thetas of 90, 180, 270, or 360, which is all the way back around. Or, to say it in radians, this is a theta of pi over 2 radians. This is a theta of pi radians. This one is 3 pi over 2 radians. And then this last one is 2 pi radians. Okay? All right, so now we're ready to take a look at a little bit of the harder problems. What is the coordinate, or are the coordinates of that point? This is x, y, and we know from before that xy is cosine theta sine theta. Now, before you get out your calculator and give me a decimal for that, we're going to do this in a different way. We want exact answers. So whenever you see that, a decimal expansion that you approximate is not fitting the bill. Okay, so let's take a look. I'm going to make a little space here. I'm going to drop our vertical down to there. That's 90-degree angle. We know this is x and this is y. So we want to find out what our coordinates are in terms of, like, what we could say in terms of square roots and things like that. Now, 90-degree angle, 45, we know that's also 45. So now we know that x and y are equal. And I'm going to break that out here. Here's that triangle. There's my x, there's my y. This is 45, and so is that. Okay? So that means this is an isosceles triangle, and the sides that are opposite of the two equal angles are also equal. So x equals y. Okay? Now we know that the hypotenuse is 1. Okay? So we can write this equation first. X squared plus y squared equals 1. We know that's true from the Pythagorean theorem. Now, since we know that x equals y, we can substitute one for the other. So now I'm going to go x squared, but since I know x and y are equal, I can just write x squared again equals 1. Okay, so I just substituted x for y in this equation. So now we can solve for x. We get 2x squared equals 1. That gives us x squared equals 1 over 2. and then take the square root, we get x equals plus minus the square root of, or 1 over the square root of 2. Okay? So now we know that the x-coordinate right there is going to be plus 1 over root 2. Okay? It's the positive because we're this side of the y-axis. We're in the positive x direction. Okay? So now I don't need to do any more calculating to find the y value. See if you can figure that out. Okay? If you remembered that since we have an isosceles triangle and these two sides are equal, we can just substitute in x for y. And y is this side of the triangle, which is also how high it is above the x-axis. So it is indeed the y value at that point. So this is also plus 1 over root 2. Now, technically, you probably realize this. I don't need to write my pluses. That's assumed. So, for a 45-degree angle, at this point, the x and y coordinates are 1 over root 2. Okay? Now, we've done all the math we need to find out the rest of these points, these other three, as we go around in 45-degree increments. This one, we're negative x, so that's negative 1 over root 2, but we're positive y, we're up. So this is 1 over root 2. So now you can figure out what these two are. Pause the video for a sec, write those down. Let's see how you did. This one, they're both negative. That's minus 1 over root 2, comma, minus 1 over root 2. And this one, the x is positive because it's still to the right of the y-axis, but it's below the x-axis, so the y value is negative. So this one is going to be 1 over root 2, comma, minus 1 over root 2. Okay? So to kind of summarize, we went around our unit circle in 45-degree angles with our theta 45, 90, 40, or 135, 180. Went all the way around in 45-degree increments, and we figured out what the coordinates of all the points are for all those different thetas, which are all divisible by 45. Okay? So we have these easy ones, which we've known of for a little while. Now you have 4 more points that you know on the unit circle that are incremented in 45-degree angles as you go around. And the truth is, in this case, there's only one value, and that's 1 over root 2. It could be positive or negative, but there's only one value for these 45-degree angles. Okay, now let's go through the same process, but this time we're going to go around our unit circle in 30-degree increments, which is pi over 6 radians. Okay, so I've drawn this out ahead of time here. We've got our 30 there. In fact, each of these little angles is 30 as we go around. Don't mind my diagram. Some of these look bigger than others. For all practical purposes, we can assume they're all 30. And then we know these points, again to review, that point is 1, 0. This point is 0, 1. This point is negative 1, 0. And this bottom point here is 0, negative 1. So those points are unchanged from before. But now we have 2, 4, 6, 8 little points to figure out. And the truth is, really, we're just going to figure out this one, and we're going to use that to do everything. In fact, I'm going to skip that step. This video is a little long, and I'm just going to go right to the chase. We can figure out, using Pythagorean theorem and different things we know about 30, 60, 90 right triangles, to know that this point, the x-coordinate is root 3 over 2, and the y-coordinate is 1/2. Okay? So that's this point right there. Now the interesting thing is if I go another 30, it's going to just switch these two values. This one now is 1/2, and this one is root 3 over 2. So here the x-coordinate is root 3 over 2, the y-coordinate is 1/2. In this case, the x-coordinate is 1/2, and the y-coordinate is root 3 over 2. Okay? So now we can just reflect this around the unit circle, keeping track of our signs. So maybe pause the video, see if you can figure out what these 2 points are. Okay, let's see how you did. The x is going to go negative. We're still above the x-axis, so the y stays positive. So this point is minus root 3 over 2, 1/2. This point, the same thing's going to happen to these 2 terms. So we're going to get minus 1/2, comma root 3 over 2 for that point. Now this point, what we're going to do is we're going to take this one and we're going to reflect it down. In fact, another way to think about this, we're in quadrant 3, everything is negative down here. So this one is root 3 minus root 3 over 2 minus 1/2. And this one over here is going to be minus 1/2 minus root 3 over 2. Okay, so we're almost all the way around. Now we could reflect these 2 points over there, or we could reflect these 2 points down. I'm going to do that one. So in this case, we're going below the y-axis or the x-axis, so the half is going to go negative. So this one's going to be root 3 over 2 comma minus 1/2. And this one is going to be 1/2 minus root 3 over 2. Okay? All right. So, before you worry that you've got to memorize this diagram and the last diagram, just know that I will give you a nice printout that shows all of these increments going around the inner circle with all the values around the outside edge, also marked in all the radian equivalents of the degrees. And I'll give that to you as a reference that you'll be able to also use on tests and quizzes. Now, that doesn't mean it's easy. You still need to know how to use this to answer some questions. So let's do some of those. We didn't do the questions for the multiples of 45, but we can do them for multiples of 30. So here's some questions for you. Exact values of. Okay, so remember, when it says exact value, it probably means don't use your calculator. Or if you do use your calculator and you get a big old decimal on there, if it asked for exact, that decimal is not going to get you full points on a test or a quiz. So, let's do this. What is the exact value of sine of 60? Okay, now sine of 60, here's 30. We're up at 60 now. We've gone up 2 30s. So we're at that point. And remember, sine is the y value, right? Cosine is the x value, sine is the y value. So sine 60 is just root 3 over 2. Pretty simple. Now, if you wanted to verify that, you could pull out your calculator, put in sine of 60, write down that decimal expansion, then do the same thing, but now do the square root of 3 and divide that by 2. It should be the same exact decimal expansion. Okay? So let's try another one. Let's try cosine of, let's do 120. What's the exact value of the cosine of 120? So we have to think. Actually, pause the video, see if you can get that. Okay, let's see how you did. 120 is 4 30s, because there's 30, 60, 90, 120. So we're at this point on the unit circle with 120. Cosine is the x value at 120. So the cosine of 120 is minus 1/2. And again, if you put that in your calculator, if you do cosine 120, you should get negative 0.5. Let's do one more. Let's do sine of 300. What's the exact value of sine of 300? So 300 is 10 30s. So there's 3, 6, 9 30s takes us all the way to here. So the 10th one brings us all the way around to this point. That's 300 degrees. Another way to remember that is we're 90. Another 90 means at 180. The bottom is 270, but we need 300, so we're another 30, so that's right there. Okay? Now sine is the y value, so sine of 300 is minus root 3 over 2. Okay? So you could be asked a bunch of questions like these that would have you use your unit circle to figure out the exact values. So again, don't use your calculator to answer these. You can use your calculator to verify, but you want to be able to use your unit circle to answer questions like that. Now that you've finished the video, take a moment to jot down any questions that you have so you can bring them to our next class and get some help. You can also watch the video again to perfect your understanding. If you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.